And looking at page 10, this is question 12. I've got to find the highest common factor of 36, 45, 54. What I've done, I've split off these numbers into their products of primes. So 2 goes into 36, 18, 2 into 18, 3, 2 into 18, 9 times, 3 into 9, 3 times, 3 into 1 once. So we're expressing that as a power. So 2 squared is that little bit, 3 squared is that little bit, 4 times 9 makes 36, so that's fine. I've done the same with 45, expressed as a product of primes, and 54 also expressed as a product of primes. And we've now got to find the highest common factor. Alright, just look at that. Right, what do we have in common? 2 2's, no 2's, 1 2. So therefore 2 is not going to work. I've got a 3 squared there, a 3 squared there, and a 3 cubed there. Therefore I can take 3 squared from each, and that's all we have in common. There's a 5 there by itself and there's nothing else. So 3 squared is 9. So the highest common factor of 36, 45, 54 is 9. That is to say, the biggest number that goes into 36, 45 and 54 is 9. Now, the lowest common multiple, the way I like to teach it is, where will 36, 45 and 54, where will they meet up again in the future? Now we can do it the long boring way, keep adding loads and loads of 36s to get a whole load of multiples of 36, a whole load of multiples of 45 and a whole load of multiples of 54, and eventually we've got to find the number somewhere along the bottom where they all meet up at in the future. Well, that's long and boring and not very intelligent. The fact that we've gone through listing out all the products of primes will allow us to use these answers here to get the answer quite quickly. So the lowest common multiple, what you do, you take each number at a time and you take the highest power available. So let's just start with the 2's. 2 squared, haven't got one there, single 2. 2 squared is the biggest, and that will take care of the 36. Next one is 3. 3 squared, 3 squared, 3 cubed. 3 cubed is the biggest, and that takes care of that. That also takes care of the 36, and we've got to have the 5 there, so the 45 can go into this factor we're about to calculate. So 5 is required because 45 needs it. So here we go. We've taken the highest power of 2, which is 2 squared. We've taken the highest power of the 3, which is 3 cubed, and we've taken the highest power of the only remaining 5, which is 5 to the power of 1, though you don't need to write that. Now we're going to have a jolly old time working this out. Well, 2 squared is 4, 3 cubed is 27, times 5. Well, 4 5s are 20. Doesn't look too bad actually. So I've got 20 times 27. I'm not allowed to use a calculator. 2 27s are 54. Put a 0 on the end of it. 540. So there. I want to carry on with a couple more questions on page 13, rated at grade B. This is question 12. I'll get this one out of the way. It's supposed to be difficult, but it's really, really easy. This is what it says. It says the prime factorization, I better write it down, prime factorization. So the prime factorization of a certain number is 2 to the power of 3 times 3 to the power of 2, and the question is, what is the number? Well, let's just decode that. That means here is a number already expressed as a product of its prime numbers, or its prime factors. What is the actual number? Well, in other words, let's work it out. Well, that's 2 times 2 times 2, 8. That's 3 squared, 9. Now we're going to multiply them. Answer, 72. In other words, had they asked you to work out 72 as a product of its prime factors, then you'd go for the answer which is given in the original question. So here it is. So this expressed as a product of primes is 2 to the power of 3 times 3 to the power of 2, and here they gave us the actual ready-made prime factorization, and we've got to work out the number. Really, really boringly easy. I fancy question 11 because it looks tricky. Well, it's just more of the same, but a little bit more horrible. So write each of these numbers in the form of 2 to the power of, what is it, 2 to the power of A times 3 to the power of B times 5 to the power of C. Well, that looks horrifically complicated. All it means is all these numbers will have 2, 3 and 5 as prime factors, and A, B and C are merely the powers to which each factor is raised. You haven't got to worry about A, B and C as if it was some frightening algebraic expression. It's really easy. You just do it as normal as a product of primes, and we'll see how many 2's, how many 3's and how many 5's. But apparently there's not going to be any 7's or 11's or 13's because it doesn't say that in the question. So here I go. I've got 1080. I've now got to express it as a product of these prime factors. Very easy. Start with 2. 540, I believe. Yep. 2 goes into that. 250, 260, 270. Yes, of course, the half of 54 is 27. Halve it again. That's going to be 135. Okay, odd number, forget that. Try 3. 3 goes into there. 45, I believe. Yes. 3 goes into 45 15 times. Now it's getting really easy. 3 into 15 5 times, and 5 goes into himself once. So what have I got? I've got 2 to the power of 1, 2, 3 times 3 to the power of 2, 5 to the power of 1. So I can say A equals 3, there's the power there. I can say B equals 2, and I can say C equals 1. And if they wanted to be really horrid, they could have said express 1080 as a product of primes and calculate the value of A, B and C. That sounds ever so spooky and out there. No, just do products of primes like I've showed you, and then whatever the power is, that's what the letter stands for.